So once again, good evening, everyone.
Good evening, sir.
Yes, so it's, Cube 6 have been uploaded on Moodle. So I would want everyone of you to download it. Once you download it, read the question for 5 minutes. I'll also display the question on my screen if someone is unable to download from the Moodle. Uh, yeah. So this is the only question. This is one of the easiest tube we have ever got. So read the question, and after 5 minutes, we'll understand what we have to do in the question, what we have been asked, and then we will move to the solution of each of the part A, B, and C. Okay, so we'll So all of you read the question? Hello? Am I audible to you or not? Something is please.
Yes, sir, you are audible.
Yeah. So someone would like to come ahead and explain. Hello? Someone would like to come ahead and explain what has been asked in the question, what we need to do. See, if you want to keep the session interactive, then only it is meaningful to come here. Otherwise, these three codes are anyways available on the internet. You can Google it and just submit the assignment. So just interact so that more clarity comes. You get more perspective.
Sir, these points have to include 0 and 2 pi also, right?
Yes, yes, you have to include them.
So, sir, I think in this question we have to first take this interval 0 to 2 pi, and then at the interval of 1/8 interval of the whole, we have to take 8 points. After that, what we have to do is using these methods, we have to find the value of y at those points.
Okay. You have to calculate ft value. That is, are you able to see my screen now? Hello?
Yes.
Yeah. So from 0 to 2 pi, you have to take 8 equally spaced points. So in between, how many I should keep? 6, obviously.
6.
Pardon me, the points are not equally spaced here. So how many points does it take? 8. 8 points, which are equally spaced, isn't it? Hello?
Yes.
Yeah. So how many segments does it give to us?
7.
7 segments, right? So one segment is of 2 pi by 7, isn't it?
Yes, sir.
Yes.
Yeah. Yes. So what you have to calculate the value at x1 here, x2 here, x3 here, x4, x5, x6, x7, and x8. Okay. So you can calculate each one of its values for ft. Fx, sorry, fx equals to sine square x, I think. Sine square x. Sine square x. So for each of these xi's, you have to calculate fx. That is pretty straightforward. What you have to do is nothing. Uh, so this is done. Most easiest part of the assignment. Now, now suppose had this not be a sine square x, such a beautiful function as sine square x, had it not been so, and you were given some arbitrary function in your laptop only, that you can generate some points out of this, but we do not know the nature of the curve, right? Whether it is sine or exponential or something else. We do not know anything about the function, and this is very practical problem, because whenever you do a simulation, you get a graph of unknown functions, completely unknown functions, because those softwares simulate the input input variable, whatever we give the input, uh, and give us the output by numerically solving it. So numerically, we are only getting the values, and to physically understand our those things, like we can understand sine square x. No problem in understanding sine square x. We do not need polynomial in this. But if there are functions which cannot be written in a closed form like this, such as sine square x, we are only getting some data points, some random data points, some thousand data points we are getting, and we want to understand it. Then how we are going to do that? So that's why this method is here. So curve, this is called curve fitting, that for fx equal to sine square x, like sine x graph would be like uh, this, sine square x would be like this. We can easily draw its curve because we know it, and we understand it well, really well. But there may be some functions which we do not understand very well, and therefore we need these the values at certain points, that we can calculate and fit it into the known functions. Known functions, what are the best known functions? Polynomials. That's why we fit the curve into the polynomial, because polynomial can fit almost any curve. By the very definition of Taylor's theorem, Taylor's theorem just states that fx equals to, like, if we are writing fx, then it is just nothing but fa plus x minus a times f dash x at x equals to a, and x minus a square by 2 factorial times f double dash x at x equals to a. So these various things are just the modification of the most powerful Taylor's theorem. Now, in the Taylor's theorem, we uh, we might not know these. What are these coefficient f value of f dash x at a, and f double dash x at a, and so on. We do not know that. So what do we do? Would someone like to answer? Yeah. Hello.
Sir,
What
I
should?
was not able to hear. Can you repeat once again?
Yeah, yeah. So from where you were not able to hear?
What you were asking, there was some problem.
Yeah. So here, by Taylor's theorem, this is Taylor's theorem. Everybody knows it, right? Is there problem in this? No, no. Hello.
Yes, sir. Yes.
So Taylor's
Yes.
theorem is fa plus x minus a times f dash x at x equal to a plus x minus a whole square divided by 2 factorial times, and so on. I will not repeat it again. So we may not know the value of fa and fa and f dash x at x equal to a, f dash double dash x at x equal to a. We may not know that. We are just known the value of the function at variety of points x1, x2, x3 up till x8. So uh, how we are going to find out this? Like, what should we do?
Sir, we can use that Lagrange technique in which we use all the factors like x minus all the other xi's, so that like if we have to find the factor for x1, let's say, so x minus x2, x minus x3, so on, divided by x1 minus these factors, so that when we put x1 it becomes 1, and then multiply its value, y value, so that
Yes,
it becomes the thing that we require, and add all of them.
yes, that is absolutely correct, Ayush. But here I am not want to go there. But I want you to think, like, what comes to your mind when you see this? Like, can we write it just as some coefficient a naught plus a1x plus a2x square and so on till a n xn? Do you agree or not?
Yes, sir.
And these are just the coefficient. Whatever will be the value of fa, f dash a, f double dash a, and so on, whatever be the value of those, will automatically be incorporated in these. You get that?
Yes, sir.
These will be automatically satisfied once you fit these points. And one is always recommended to use the polynomial of same degree of which we have the number of points. Like, number of variables are to be kept the same as we have the number of points. So here, how many variables we are having? How many variables we are having?
7.
7. No. We will have 8 variables. Hello? Why 8?
Oh,
Why
okay,
8?
okay. Because
Yeah.
one is constant in.
One is constant in that. So seventh order yeah, this is called interpolation method. Interpolation method. In the mathematical community or in anywhere in the world, this method is popular as in the literature as interpolation method. That's why this method we are studying. So, but it is just a common sense of this Taylor's theorem. Every method is just a common sense of this, that there will be some variables. Now uh, now we can various things in this and formulate other methods. I will tell you how we will do it. uh, so fx is this and interpolation is there. So how we are going to find these coefficients? What we have x1 x2 till xi and fx1 fx2 till fxi. We have these. mm, no, oh, yeah. Someone,
Sir, we can put the values of x and then use cos elimination or Gauss Jordan.
yeah. So when we will put the value of x1 here, so it will become like, I'll show you it here only. Interpolation.
So shouldn't we have n minus 1 order polynomial? Like
It
here we
Yes, it is n minus one. Yeah, it should be n minus one order polynomial. Yeah, right. Where n is the number of points you know. Just have it in the flow. A n x n. Strictly, it should be a n minus one. But I hope you got the idea, right? No? Yeah. So when we put these values, once we put x1, this will form this first row. When we put x2, this will form second row, and so on till xn. We put that, and corresponding values of y are given as f. Like y1 is fx1, y2 is fx2, and this is fxn. Now what now this is clearly a n by n equation, and n linear equation. These are n simultaneous linear equations. So how we are going to solve these? Like we are going to get it in the same way that a x equals to something b. Here some here notation is different. Like this was our notation standard notation, but here it is something like x times a's are is equals to y. Now one can say, uh, what should we write as a? A is a matrix vector, a naught a1 till an. Hello. So how we will find a? Hello.
X transpose X inverse times X inverse.
Yeah. Finally, it is x inverse y, but
Yes.
we can write it as x transpose x times x transpose here times 1, isn't it? Why we are doing it so that its inverse can be easily calculated when it is it is not able to transform. It is not invertible. When x is not invertible, we use this is very helpful. It gives inverse correctly, values of a's correctly. So you have the code of Gauss Jordan implemented with you. Hello, hello.
Yes, sir.
So Gauss Jordan method, by that you can calculate the inverse. You can calculate.
Yes.
So then, is there something in the problem?
Sir, it is written that if the order is greater than 6, then there will be problem in calculating numbers.
Yeah. So like inversing is n cube, no? O(n) cube operations you have to take. So it is just difficult in that sense. It is time complexity. Time complexity is high, so it becomes difficult. Understood?
Sir, Gauss elimination is a little faster, right? So we can put the values of an x and then try maybe. But it is also, I think, of the order n.
Gauss elimination. So when you are applying the Gauss Jordan method, what you are doing is you are fundamentally applying the Gauss elimination method only with partial pivoting, and so on.
Yes, sir.
So if it will not perform partial pivoting, then also it will not be correct. Would it be correct?
Yes.
So here it is written difficult for human beings to calculate. You take it like that. It is difficult for human beings to calculate. Your computer will calculate very easily. No issues at all. Will do it like butter. Uh, so it will be very easy to calculate. So I give you 5 minutes to think about how we are going to code this. And tell me how we are going to code this. We have done it before and discussed it before, but I want you to tell me that how we are going to do this. So I give you 5 minutes to think about it. Meanwhile, if anyone have any doubt, he or she can ask.
Hello. So someone quickly tell me how we are going to code it. Just the pseudocoder, step by step. Someone go ahead. Hello.
So first with the points we have, we'll find y vector, that is the fx any sine square x,
Okay. Where to find y. Okay.
and then x matrix, that is each column is the increasing power from 1 to x n minus 1, we'll find x matrix.
Okay. Where to find x matrix. So can you tell me how we are going to find it, the x matrix? Like
uh,
what kind of code are you going to write while writing?
so with column number, with each iteration for column, that column number will be the power, x will be raised to that
Okay.
power.
X will be raised to that power. So uh, like I am calculating x1 square here. So I will write x1 raised to the power 2. But there
Yes.
is no direct function of power in C++. I don't know. Even if it is there, it is not so time efficient. So would you how you would do this power? That was the purpose of asking this. How you are going to
So
make.
can't we simply use power function?
Sir, it is there in C++ named POW, where the first entry is the base and the
Matters.
second entry is the power.
Okay.
Yes,
So can you tell me the time complexity of this?
So it will be, oh, I think n
We
q.
can. Okay. So
Sir,
when
it
we are,
is
yeah.
sir, it is a log n where n is the power.
Okay, Logan. We assume Logan.
N is the power, yes.
So when you are calculating this uh, log 1 plus log 2 and up till log n. This complexity you are saying times n. Shall I do it? Hello. Hello.
Um, no, sir, like if we
So
are
it
doing,
is around n log n, isn't it? This is same as n log n. Can we write it? Do you guys agree or not that this is n log n? Order of n log n. You agree? You you studied the time complexity analysis in your your question. Hello.
um, sir, like log n for calculating each power. Then we are calculating for each row, so it becomes n log n, big of n log n. And then for each column,
Yeah.
it will again n operations. So it should
Uh,
be n square log n, no?
yeah. I was talking of just this row. Just this row.
Yes, n log n, yes, sir.
Yeah. For just this row, it is n log n. then we cal then we calculate it for column, so it becomes n square log n, right? So it is highly time complex. The time complexity is very high. Like log n factor is coming here. So one efficient way of doing this, while you are making the elements of this row, you can just multiply the previous, and you can just initiate it by 1 and just multiply it by x1. Then the corresponding element just to the next of it. You will be applying loops for that, and you just write that this element will be the x1 times of previous. Similarly, while you are making this column, you can write the x2 times previous here, x2 times previous, so it will become x2 square. So here you are calculating the power, nth power, in O1 time. O1 time you are calculating because you already have stored previous one, and you are just calculating this next one. So it is O1. Multiplication is O1. So it will be just n square. You have drastically reduced the time complexity of your process here while making x. One thing to keep in mind. I hope I'm clear. If there is any doubt, please ask. If I,
Okay, sir.
so once you make x, once you make y, then you can make the multiplication function also. Then you can make inverse function also. Inverse function will have Gauss Jordan working inside it. Gauss Jordan. Now, what else is left? Transpose is left. Will make the function of transpose also, and we'll finally execute our main code just like this, like a equals to whatever the formula, x transpose time x whole inverse multiplied by x transpose times y. So we can directly calculate it. We pass x in this we will get the transpose. So this is written in one line. One line. You can find a in literally one line. No issues with that. Now what, and I'll come to that point later of time complexity and so on. Like what now, how much time it takes? This method takes how much time? What is the highest time taking step in this whole process? No, no.
Sir, inverse. Um,
Yeah, inverse. Inverse is calculated in n cube, right? So this is the most time taking part in this. So definitely this one can't be the efficient solution, right? When O(n) cube is your time complexity of calculating the coefficient of the interpolating polynomial, we need to think about different other methods to do this. Now, what are those other methods? One method is Lagrangian or Lagrangian. Yeah, Lagrangian interpolation. So, as Ayush already told in the beginning, that how uh, this is defined. So, suppose we are just approximating it like this. It is not given how we are exactly going to write it. For example, it is given very well. So how we are going to write it is f x2 equals to p1x times x2 plus p some coefficient of this. I'll write it here. So p1, suppose instead of x 1 x square and up till x to the power n minus 1, we do not choose to use this. We do not choose to use this. We use some polynomials p1x, p2x, p3x, and so on. We do not know about these now. So we can write it like it will be some coefficient times p1x, some coefficient times p2 p2x plus some coefficient times p3x and so on, or whatever our desired function is. F of x can be written like this because since all these can be expressed eventually in form of these, so this coefficient will take care of what happens in the end. Now we have to very smartly formulate P1, P2, P3 so that our work of finding these coefficient is minimized. Uh, what we have to eventually find is these coefficients. These polynomials we can construct by our way. So uh, Lagrange gave a very smart method of calculating uh, uh, the coefficients. He just defined his own polynomials. So what are those polynomials? It is just a matter of design and nothing uh, very conceptual into it. It is just a matter of design. So what he thought was that what we are doing is we are just putting it x1. Let us put x1 in this. So a1 times p1 x1 plus a2 times p2 x2 x1 plus a3 times p1 p3 x1 and so on. So he wanted to calculate a1 instantaneously. Like you have p1x, p2x, p3x. Once you have those, you want to calculate this a1 very fast. Just you put x1 and you get the value of a1. You did not wanted to apply the whole Gauss Jordan method to get the value of a1, a2, a3, and so on. Did not want to do. So what? How can we do that? Like only possibility in that scenario is we take at x1 this value to be 0, this value to be 0, and all the rest of the values p4, p5 at x1 to be 0. And you could have taken arbitrary value of this, like any value you take, not 0, of course. Otherwise, this will make no sense. So you have to design a polynomial such that you can calculate a1 very just by putting the value of x1 in this function. So a1. So let's take the polynomial's value at x1 is 1. Yeah, now we'll design that polynomial later on. Like I'm just uh, going through the derivation a little bit because there is nothing to do in this assignment. Just you have to understand the how curve fitting is thought. You have to just think about it. How can we fit a curve in a particular function or so? Uh, Otherwise, there is nothing in this assignment. Like you can just s- see see. Uh, So fx1 divided by p1 x1 that we have taken to be 1, right? So now what he constructed was this. He defined as pi x equals to, this is product sign, all of you must know. Uh, this is for some p1 we are, suppose p1 we are calculating, so we will write here x minus xj, the product of all the j xj x minus xj, where j is not equal to I, because if j equals to I, then when we put x equals to I in this, like suppose it is x1 I equals to 1, so if we put x equal to x1, so it will become 0 then, but we do not want to be, so we want it to be 1 at x1 1, and at rest of the x we want it to be 0. Are you all getting it, or it is not making sense at all? Is someone getting it? No one is getting it.
Yes, sir. Understood, sir.
So so that's how this is designed. So you can of course design it by for using for loops, like you can apply two loops and just calculate your pix. Uh, so I would give you some 2-3 minutes to think about like how you would apply some loops to calculate pix, what you would actually do in pseudocode terms. Like we have understood the idea, like once we have these p1, now here we do not have to find these coefficients. Coefficients are already known to us in terms of fx1, fx2, and so on, because as we do it, put x1 into this, we get a1 equals to fx1, similarly a2 equals to fx2, and so on. An equal to an minus 1 equal to fx minus 1, or an equals to fxn, right? Are you all getting this, no? So you have to figure out a way how you will calculate pix in code, in pseudocode terms. So think about it for a couple of minutes and we'll discuss. Just write the formula here, or just move to that slide only. Yeah. Try to think for a minute. So anybody with the answer? Go ahead.
Yes, sir.
Yeah.
Uh, sir, we have the points x1, y1, x2, y2 till xn, yn. So we can first take the input, or we can calculate like 8 points we have to calculate. So we can calculate those 8 points in
Yeah.
two arrays, one for x and one array for y.
We
Then
have
we
to
can,
fx1 fxi is only no? Here in the array.
yes, yes, sir.
Uh,
Yes. In two arrays, we will store those 8 points, x coordinates and y coordinates.
okay.
Uh, then we can declare a function for calculating that pix function, pix for calculating that. In that, we will pass x array, y array, I, and we will pass I in that. Then we will run this loop for calculating pix. We will run this loop that for j is equals to 1 to n and j is not equal to I, we will multiply x minus xj upon xi minus xj, and x also we can take the input like x1, x2, x3. So we can calculate p1, p2, p3 coefficients we can calculate.
Okay. That's absolutely correct. Just we have to store it in some variable equals to variable multiplication equals to. That's how we, isn't it? So you the code part you will figure out yourself how to write this. So the basic funda is this only. We have to define a function here. You have to write a loop here, and got the PIX. No problem. And once you got the PIX, you got everything. You got the polynomial. You have to find the PIX only. Don't choose rest. Is it fine? So once you find the PIX, you have to make a big function like actual polynomial function, approximating function. You have to write this. You have to complete this approximating function. Once you calculate all the polynomials, you'll take in the say the input as whatever you want to take like fx values like y values as input and some number n like number of points you have that these both things as input and you can easily approximate it, right? How you like approximate it? Someone would like to tell. It is written here only. Just read it out for the class. Hello, hello. Saying just read it out for the class. Okay, I'll read it out. We'll approximate it by fx fx1. You have the value. You have the polynomial. This you will write by this. Then okay, you write fx2 p p2x and so on. You calculate this. This will be calculated by using a loop, and you have to return what will be the value of x after this. Return this variable after summing up whole, that this variable you have to return, which will be the approximated value. Like you have to take the input of the what you have to approximate, which value you have to approximate that. Now, can someone tell me the time complexity of this? Time complexity. What will be the time complexity? What will be the time complexity for this?
Sir, n square, big O n square.
Yeah. We go n square.
Yes.
So it is comparatively efficient method. You get all of you can clearly see it. Like we are doing simple interpolation to what we came to Lagrangian. So does there exist any more easy method than this, or more efficient method in terms of time than this? We don't know. Till now. We don't know till now. So the third method which we have to analyze as given in the tutorial is the Newton's divided difference. Pardon me, guys. Yeah. So we have been asked to calculate the, the, the value of the function by the third method, which is Newton's divided difference formula. So how we are going to do that? Anyone have any idea about that? Newton's divided difference. No. So all of you have slides now. I'll give you 5 minutes. Read it from the slides, and then we'll discuss. Because if I cannot start giving you basic from the basics, right? So you just uh, download this lecture number 19 and see through it, and after 5 minutes we shall discuss what is there in this. Okay. Hello, everyone read about it?
Yes, sir.
Yeah. So, would you like to explain to the class that what you understood? You,
Sir, like it can be linear, quadratic, and cubic also. So we have to choose cubic one, na, because our function is cubic, sine square x.
uh, yeah. Uh, so, which one should you choose?
Oh,
Like,
sorry, quadratic,
f-
quadratic.
first of all, just tell me in brief that what we are doing in this. Like, how different is it from previous two ones? How it is different
Sir,
from?
here we are connecting the points by a line,
Okay. Yes, we are connected.
and the equation of the line is like as you are shown. Equation of the line is given
Ah,
by the y and x of two chosen points.
yes. So this is only linear interpolation. This is linear interpolation. When we connect the dots by the lines, that is linear interpolation. We connect every 2 points by the line. Every 2 points by a line. Now there can be quadratic, there can be cubic, and there can be any degree a polynomial interpolation. So the degree will not differ in any of the three methods. Let's make it clear that in the Newton's, yeah, sure. In the Newton's difference method also, the thing will not differ. So what we are doing is the degree will be x7. Degree will remain the same. The polynomial will change. As I explained here, you can express fx as this. Sorry, guys, 1 minute. Yeah. So you can express any polynomial as like this, like sum of uh, the coefficients multiplied by the polynomial. Coefficients multiplied by the polynomial. Now it is our duty how to decide the polynomials, what we are choosing. But the degree does not differ in any of the polynomial because what we have got ultimately are eight. Like here, it is we are given n points. So we will have n equations corresponding to these n points. Now to we should have n equations for these n points. So we must have that much degree of the polynomial at least to solve for them. Otherwise, if it would be like 1 degree polynomial or 2 degree polynomial, then it will just overfit. Uh, sorry, underfit that these conditions. Like if it is a the points are like this, and you are trying to connect them by single line, that it is not possible. By single line connecting them is not possible. If you try and connecting the dots by lines from here itself, then it is called this interpolating method. And if you directly fit these points into this line, this will be the regression that will come in the later tutorials. We are not discussing that here. Now, in order to better fit the points, you take the uh, take the polynomial is of degree 2, so it will directly fit. It will directly fit into this with no issue. Mm. So the problem comes is that you do not have to underfit. Underfitting is not allowed. Overfitting not allowed. So we are given with 8 space points. We'll take a, n minus 1. That is seventh degree polynomial. Every time. The degree question should not come in your mind. That what would be the degree of the approximate also. Approximate polynomial. So if we are given with 8 points, the degree is definitely 7. Now the question is how we will choose P1x, P2x, and so on. No, why? Like I'll just tell you what are the uh, values of the polynomials that we are choosing here. I will not here explain why did we choose it, because why did we choose it is very well explained by ma'am, and you must refer to it, to the videos or these PDFs. You should refer to it for that. Here what I'll explain it, how to use that. What is P naught x? What is P naught x? It's definitely 1. You have to take it Pn minus 1. Yeah. So it is 1. Everyone agrees with that. That the zero degree polynomial is 1. Yeah. No. So we are given with 8 points. So what will be the P1x? What will be the P1x?
X1.
See, that's your choice how you are making, but it is not actually x1. It is of 1 degree, x minus f1, and only first we have to take, only first. Similarly, p2 is defined to be quadratic, x minus x1 times x minus x2. Is it clear?
Okay, sir.
So and so on till you have to take it till the x minus x1, x minus x2, and so on up till x minus x. What should I write here? It's 7, right? Now these are the polynomials. Now you have to find the coefficient of this so that this becomes equal to fx, isn't it? You have to write the coefficient of this so that it becomes fx. Now, how are we going to find the coefficient of this? That's the question. The whole question. Once we have formulated the polynomial, so because here, like in the Lagrange case, it is not possible to simply find out the coefficient just by looking at it. Like in that case, it was simply fx1, fx2, fx3. Uh, Here, it will. How we will find it? Would someone like to tell? Hello.
Hello.
Yeah.
Sir, we are writing f and x as this general form. So if we put x is equals to x0, so all the terms except b0 will become 0. So we
Yes.
will get b0. Then we
Yes.
will put x1. So all the terms after b1 will become 0. So we will get b1 and we will get b2 the coefficients like this.
Yeah. Exactly. It's perfectly fine. Okay. So, so as Tokyo said, put x equal to x0 here. You find b naught as whatever f and x0, and so on the values of subsequent. Now I give you 5 minutes. Now think upon how can you code this up. Okay, so think about it. How can you code this solution? This simple backtracking that we did in case of uh, Gauss elimination while finding the solution of those n linear equations. Okay, think about the pseudocode. Then we will discuss it.
Excuse me, sir. Excuse me, sir.
Please go ahead.
Sir, can you please repeat what you said about putting x in that equation? You said something about x0, right?
Yes. Yes. Okay. Hello. Yes, Himanshi. So uh, what you do, hello, am I audible to you?
Yes, sir.
Yeah. So what you should do is first put x equal to x0. Uh, in here, uh, I had taken it to be x1, x2 up till xn. They have taken to be x0, x1 up till xn minus 1, that is x7 in our case. That much is clear now.
Yes,
Yeah,
sir.
yeah. So first we put x equal to x0. When you put x equal to x0, all the subsequent polynomials except this becomes zero.
Yes.
Yeah. So b naught is directly calculated as fn of x0, isn't it?
Okay, sir. Okay.
Now for calculating b1, you put x equal to
X1.
x1.
Okay,
So
okay.
all the points, all the polynomials beyond this become zero. And now you have the value of b naught from previous one we already know b naught. So then we can easily calculate the b1 from here. So I hope that makes sense now.
Yes, sir. Now I got it.
So, so someone would like to tell how we are going to code this. So someone would like to code it. Shall I just write what you have to do, major steps? I think I should write. We are not anything in the mood of telling. So, so you have to define y, x as usual. Okay. Then you have to define what will be the pix. Pi. So pix. Now this one we are going to tell you how we are going to find pix. Either you tell me now or you do it yourself. So someone would like to uh, come up and tell us how we are going to calculate pix. No?
Hello.
Yeah.
Sir, we can make an array for P. The first element P0x is 1. For calculating P1, we will multiply x minus x1 to the previous element of this P array. Then for P2x, we will multiply x minus x2 to the previous element of this array. So this way we can calculate all the functions.
Hmm. That is one way that all the functions are stored in your array by that, and you can access anytime in O1. So that is a very nice approach in that sense. But what will be the more convenient way? Like you can always make an array, no issues in that. Is to just calculate the ith one and not calculate p0, p1, and pn minus 1 in one go. Don't prefer that approach. Like he- what you want to here, we are building the solution step by step. So what we want firstly, x, y, we have. What we want next, we want p0, p1, p2, and so on. So you can directly use it, like you apply a loop and you find the x minus x1 times x minus x2 and so on. You find that. Sorry, I mistakenly said it wrong. You have to develop an array for this. I take my words back. You should develop an array for it and store one in this x minus x1. So Takir said absolutely right. For second polynomial, you have to just multiply it by x minus x2. So don't take my previous words. I take those words back. So make an array and just then rest follows. You know what you have to do is you have to make an approximating function because why I'm not telling it you have to make it pix in one go because it will increase the time complexity. Here you are making it in O1. Now you will be taking O n time for each one of them, so it will be n square there only. So you don't have to do that. You have to just make the whole array in On. You can make this in On. Uh, all of you agree with me in this part. Hello?
So, sir, you mean that the next element of the array will be the multiplication of previous element by the preceding value?
Yeah, yes,
Okay.
exactly. The next element of the array will be the just multiplication of the preceding by x minus uh, whatever x I is there. So this will be calculated now. What will be the approximating function? What will be the parameters that you will be passing in this? Any anyone?
Sir, the array, this P array, and all the coefficients.
All, all the coefficients will pass. Right. Okay, all the coefficient will the coefficient how will pass?
Um, Sir, we can calculate one array for coefficients also, no? That a0, a1 till an minus 1.
So
An.
we have to write one more function, right?
Uh, yes, sir.
To calculate coefficient, whatever you say. We calculate the coefficient. And how much time we calculate the coefficient?
Sir, big of n.
Because because we in we calculated the whole array of this pix px. Let's call it px, which returns this array we are returning, and in on time we find out what is the value of function, and in next on time we are finding out each and every coefficient by just backtracking. So am I clear with that? Hello. If anyone doesn't understand how do we have to find the coefficient, then please ask.
Hello. Everyone understand how we have to find the coefficient?
Yes, sir.
Yeah. So once we have the coefficients, then we are writing the approximating function. We are taking the we are taking only x as input and the coefficient whatever the coefficient array is there, we are taking that as input. So we are calculating this fun- the, this array of the polynomial, interpolating polynomial on the basis of this. We have to define this array as px. So this will give us array. I'm writing the pseudocode, so it, it may not be written like this in C++. This is just a pseudocode. So once you have all this array, then you can just in on by a loop find out what will be the value of this f of x by just approximating through this. Fx equals to, what is fx? A1 times p1x, let's say 2 times p2x plus a naught, and so on, isn't it?
Yes, sir.
So that's how we calculate the approximating function in this. I hope this is clear. If anyone have any kind of doubt in any of the step, please ask. Okay, then it is clear to all of you. So this last thing, tell me the time complexity of this. Just tell me the time complexity of this.
Yes, big of n.
Big of a. So moving from n cube, we move to n square, then we move to n cube, n. So that's how we are moving towards a more efficient method for doing the same thing. Like it is just assuming the polynomials. We could assume any arbitrary thing. We can assume any arbitrary thing, but we have to move towards most obvious to most efficient. This is most obvious to most efficient. Yeah. So from most obvious to most efficient, we have to find. Is that clear? Now the error analysis part of each of these is given in the book also and is given in this PDF also. So error analysis part, I want all of you to include in your report very seriously, because the next thing comes to time like is error only. The error is central to anything. Like you are approximating it ultimately. So how much error is there in your approximation, that matters a lot. So I want every one of you to read that from book or from PDF of lectures and include it in your reports. If you have any doubt in calculating, doing the error analysis, it is pretty straightforward. Nothing, no rocket science in calculating the errors. It is direct formula is given there. You have to just use it. So I hope that you all will do. And if still there is some doubt, you can just post your doubt in assignment doubt thread. No personal messages. I'll not uh, entertain any personal messages. Doubt thread channel. You have to put your queries regarding assignment about not only error analysis but anything. So in the report, you have to definitely explain the approach In addition to this, you have to analyze the time complexity of this of your code and error analysis. So three things have to be included in the report. First is your approach. Second is time complexity. Third is error analysis. And you may also include the conclusion part. Depends on your wish. Yeah, but these things should be there in your report. Be very straightforward. So if anyone have any doubt now, he or she may ask. Yeah, Ansari had one doubt in that Lagrangian. Ansari, you had doubt in Lagrangian only, na, that we can define 2D array.
Yeah, sir, I got it cleared. It will be a identity matrix, but for any arbitrary x, we have to define it in a function wise.
Yeah, yeah, definitely. That's the correct understanding of it. So I hope this session was informative to you. Thank you, everyone. If anyone have any doubt, we can stay for two more minutes. Otherwise, we shall disperse.
Sir, can you please provide the term papers of previous year?
Yes, we will upload it. No issues. Yeah,
Sir,
regarding term paper, you have to submit the topic. We will provide the link of Google Sheets on the Moodle itself, where you will have to write your team name, with whom you are forming the team, and your topic of the term paper. Okay, and we will also be uploading the sample term paper reports. So, any more doubts? Yeah.
sir, what would be the deadline?
It would be before the majors. Before the
Okay, sir.
majors. So, okay then, let's call it a day.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.